Okay, so this problem is asking us about a situation in which a 15,000 kilogram truck is moving southward at 20 meters per second initially, and a 2,000 kilogram car is moving at 30 meters per second west initially. So what it's asking essentially is what their velocity and direction will be once those two vehicles collide in a way that is inelastic, or essentially those two masses after their collision will stick together. So you can kind of see how this is tied to what we've been learning this week, as we can use some of our conservation of momentum equations to solve for their final velocity and direction. So we can go ahead and get started with that. So the first thing that we're going to have to do is solve for that final velocity in both situations in both directions, essentially. So I showed that we're going to be using that m1v1 plus m2v2 equals m1 plus m2 times v equation, which is, like I said, prior tied to that conservation of momentum concept that we've been learning this week. So the initial momentum of these two cars as a system will equal the momentum at the end. So you can see where I've just plugged in some of the knowns we have in that west direction, meaning that the car traveling south will have no momentum in that direction, but the car traveling west obviously will. And I just divided that by the combined masses of those two cars, which is directly tied to the fact that this is an inelastic collision. And then I just rearranged it, giving us what that final velocity in the west direction will be, which is 3.53. So now we can look at it in the southern direction, where I did the exact same thing, except except the car traveling the westward direction is the one that has zero momentum in this direction. And we end up with a final velocity in that southern direction of 17.65. So this whole part can be kind of tricky, just kind of understanding how to set it up, and also making sure you read the problem carefully and realize that for whatever reason, the west direction in this situation is in the positive x direction. So keeping that in mind, I think, will make the problem a little easier. So the final thing that we have to do to find the velocity is just utilize the Pythagorean theorem. Since those two velocities you can see essentially form a triangle, we can use the Pythagorean theorem to find that hypotenuse, which will be that total velocity that is in some direction that we'll solve for next. So that gives us a final velocity of 18 meters per second. So now we just have to solve for the direction, and once again we're just going to use some of our geometry triangle stuff. And it gives us a direction of 78.7 degrees southwest. So that is it for this problem. It makes sense to me that the direction of this car will be pointed so more towards the north than toward more west. It's much more north than south, essentially. I mean, my bad, it's much more south than west, because you can see how much bigger the momentum is, 300,000 in that southern direction versus 60,000 in that western direction. So this comes as no surprise. But that is the end of the problem. Thank you for watching.